Yeah, so we're gonna be doing question three, which is based on Newton's second law. And then after this, I think after this you guys can ask me questions because I think our meeting is gonna cut short at 20 to 10. So I just hope that we can finish doing this question by then. So they say a box with a mass of 45 kilograms is pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal, and the box moves at a constant velocity. So just from the statement, you should be able to decipher a few things. Um, you have your mass, which is fine, and you know that your box is only moving horizontally, so you know that the net vertical force is going to be zero. And they tell you that the box is also moving at a constant velocity. So your horizontal net force is also going to be zero, because constant velocity means that your acceleration is zero. I think I showed you Zach and Jason in class why constant velocity means acceleration is equal to zero. So I don't think we should get deep into that. But anyway, the first question, they want you to define kinetic frictional force. Can someone define that for me? Because I'm not really gonna define that many things. I'm just gonna ask you guys for the definitions. So can you define kinetic frictional force? Just any of you, just like one at a time.
So, is it the force that is counteracting another force by producing frictional force?
Yeah, 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 yeah. That's actually a way more weighty. How can I say it? That's a more straightforward definition. So yeah, that's actually good, because you're saying counteracting, but you can just say the force that's opposing the motion of an object when it's moving, because it's kinetic frictional force. But that's spot on. You can also write that. And then Jason, sorry, did you go through this question?
Yes, sir.
Okay, okay. But either way, I saw the question that you sent me. Um, I want I want us to let's just do this one first. If we have time, we'll do that question. If we don't have time, I can help you through it on Monday during our consultation session, or I can
Yes,
just
sir.
or I can make time. Me and you can organize a session where we can do this. We can do that question together if we don't get the chance here. So, can anyone state Newton's second law of motion? Just you know, I just wanna know if you understand what we're doing. So, Kyle, can you try to state Newton's second law of motion?
So is it where when a net force acts on an object, then that acceleration? Wait, no, sir.
Nah, nah, nah.
That
You're
acceleration.
actually right. Just go on.
Okay, then that acceleration is directly proportional to that net force,
Yes,
and the mass is indirectly proportional.
exactly,
So,
exactly. Like,
Okay.
I got an assessed inability of a body change that by its state of rest or state of uniform motion along a straight line.
uh, sorry,
So
I'm
I
saying,
got that in.
We're talking about Newton's second law.
Okay.
Okay, I'm sorry. I'm sorry. Maybe my voice is not loud enough. So Kyle, like Kyle's definition is correct. It just lacks a few words here and there because like you said all the key words correctly in the correct order. It just lacks a few words here and there. So if they ask you to state Newton's, oh yeah, sorry. Here they're asking for Newton's first law, but I'm just gonna state Newton's second law for you. You're gonna say if a net force is applied on an object, the object is gonna accelerate, and that acceleration is directly proportional to the net force and indirectly proportional to the mass of the object. Is really like so, Kyle, your definition was correct, and yeah. Um. Anyway, since I can't see properly, and I said ask for Newton's second law, Zach, can you try Newton's first law of motion? If there isn't that much noise in the background and we can hear you properly. Sorry, did you hear me? Okay, I guess it's fine. Jason, can you give it a try? Newton's first law of motion.
So which question?
Question 3.2.
So which law we busy with now, sir?
No, I'm just saying like, can you answer question 3.2? They say state Newton's first law of motion.
Okay, sir. The law of inertia states that inertia is the inability of a body change that by its state of rest or state of uniform motion along a straight line.
Oh, okay. That like okay. What I can say is that is that what you got from your textbook? Because
So that's what I got from Google, so because I studied the Google definition.
man, like so sorry.
So I got an object will remain at rest to move in a straight line at constant velocity unless it is acted upon by a non-zero force.
You see exactly like I don't recommend you using Google for your definitions. Zach's definition is actually correct. If you use Google, like they're gonna give you like varsity level or tertiary level definitions because I can hear you talking about inertia and all those stuff. I don't know if I don't even think you guys have been taught about inertia yet because you're gonna learn about it next year. So that's what I'm saying. Like, don't use Google. Use the textbook. Write the definition from the textbook. And yes, Newton's first law of motion states that an object will stay at rest or in constant motion until it is acted upon by an unbalanced force or an external force. That's Newton's first law of motion. Like you don't have to include all these complex words and stuff. So we're gonna go to question 3.3. They say calculate the magnitude of the horizontal component of the applied force. And I'm sure at this point, all of you guys know how to calculate the magnitude of the horizontal component when it's given to you like this, because it's basically this. If you remember from vectors in 2 dimensions, basically like this. Sorry if my numbers look a bit off, but I'm using the mouse on my PC, so it's not the most accurate thing you could ever have. So, 5 degrees. So can you guys just quickly calculate that for me? Calculate the magnitude of the horizontal component for me. And yeah, just write it down in the chat, or you can just say it out loud.
I got 57,85.
57,85. Yeah. Did we all get the same answer?
Yes, sir. Kyle said the same answer in the chat now.
Okay, thanks. So I also got 57.85. So I guess like this is a simple enough question, but we're just gonna need it, because for physics, the answer to the previous question is needed for the next question most of the time. So the next question, they want you to calculate the magnitude of the normal force. So do you guys think you'll be able to do that, or do you just want me to like show it to you or give you some clues?
Sir,
I got 29,93 or 28,93.
The problem is that you can say the number, but it's all about the steps. So you just have to, you can, let's say, explain the steps to me, what you did, and I'll also calculate it here on the whiteboard. So yeah.
sir,
Yes,
so I just want to ask, is this where you where you have to use gravitational force as well?
exactly.
Okay, yes, sir, then I understand.
Then I definitely did it wrong, sir.
Okay, so I'm gonna give you the steps, né? And then I'm also gonna calculate for you on the side. So what you're gonna do is, you know that the net force, the net vertical force, so we're gonna have our free body diagram, and we have this is gonna be our normal, and this is gonna be our gravitational force. Let me just see weight. But there's also another force here, which you can see because the force applied is being applied at a particular angle. So it has a vertical component and a horizontal component. Or let me just draw them on the diagram. So it's gonna have a vertical component, which is gonna be somewhere from here to all the way up there, and a horizontal component, which is this one. So we found our horizontal component, which is 57.85 newtons. Now we have to find our vertical component. So I'm just gonna say force applied Y. So since we know that this thing, the box is moving horizontally and it's not going up, we know that our weight is equal to the normal force. Oh, sorry. Our weight plus the normal force plus our applied force vertically is gonna give you 0 newtons. Do you understand that so far?
Yes, sir.
Okay. So since the box is not going up and it's not going down, our acceleration is 0, so our net force is 0. So what do you have to do now is say F net is equal to, or F net Y, if you want to be more specific, is going to be equal to where's that? Just erase this. I'm just gonna write it. It's gonna be equal to mg, which is our gravitational force. Since our gravity is going down, we're gonna say negative mg. Or we already know that mg is negative, but whatever. Negative mg. We're gonna add our force applied added to our normal force. So I'm pretty sure you guys know how we're gonna find mg, and you know how we're gonna find our force applied, right?
So is it where you have to say F sin theta?
Exactly. For our force applied, we're gonna have to say F sine theta, because we found our horizontal component. Now we're gonna have to find the vertical component. So it's gonna be very easy. This is adjacent and this is opposite. So yeah, you can use sine theta. Can you just quickly do that? So we already have our number for, oh, sorry, our value for the vertical component. Can you just do that from your side, please? 5. This looks terrible. I'll just erase this and write it. So we're gonna have negative into 45 times 9.8. You guys are using 9.8 for your gravitational acceleration, right?
Yes, sir.
Okay. And then this is gonna be added to, did you find your force applied vertical component?
So it's 68.94.
68.94, right? Okay, so I'm just gonna write 68.94 plus our normal force. So you can see we have this, and then what we also know is that our F net is equal to 0. So we're gonna end up with, can you just quickly calculate this and take it to the other side, so we're left with our normal force on the side? Because this doesn't really have to have that many steps. So it's gonna be negative 45 times 9.8, negative 441 plus 68.94. So from my side, sorry?
Is it negative 372.06?
Exactly. So I also got it, but it's negative 372 when it's still on this, sorry. When it's still on when it's still on the right hand side, but when you're gonna move it to the left hand side, or yeah, when you're gonna move it to the left hand side, you know, it's gonna change from negative to positive, right? So you're gonna be
Yes, sir.
left with this. So this is your answer for the normal force.
So,
Yes.
so I thought now, is there maybe like, is there like a quicker way of doing this? Because I feel like there might be.
Not really. It's a formal question. There shouldn't be a quicker way to do this. This is actually, the thing is, you don't have to draw this free body diagram, right? This is just to help you with the directions. That's why I drew it. This is actually just a 3-step question. You see, you have 1 mark for this, and then you're gonna have two, you're gonna have 1, 2 marks here. And this is actually, yeah.
Because so
Sorry.
there's this formula that I have written here. It says that Fn is equal to Fg minus the Fa y.
Yeah, but that's basically what's happening here. It's just that you know that F net is 0, right? So
Yes, sir.
they just basically took this n to this side because this is 0. Then I wrote it as capital letter N, but sometimes they also write it as Fn for the normal force. So they just took this, put it to the side, left this as it is. This is gonna be positive, and this is gonna be negative now. So do you understand that?
Yes, sir.
Yeah, so basically still the same, still the same. So now we're gonna go to actually, you know what? Since it's already telling me that I have 10 minutes left, let's stop here and then join for another meeting so that we don't get cut halfway we don't get cut abruptly after halfway. So can I stop this here, and then I'm gonna upload the videos in 2 parts on YouTube. So is that fine? I'm gonna stop and start a new meeting.
Yes, sir.
Okay.